Kenny, you want to go to the first slide there, I think. We're seeing. All right. Hi. Welcome to our latest TechCast. I'm Charlie Berger, and I just want to go through some introductory administrative kind of instructions here as we get going here. This is being recorded, so anything that is said or any Q&A questions that you pop in here would be recorded. My name is Charlie Berger. I'm your host for today's Analytics and Data TechCast. That will start immediately following this brief introduction. My background is that I'm associated with both Oracle as a product manager for the machine learning and the BIWA user community, which runs these Analytics and Data Summit TechCasts. We're going to have a great speaker today, Kenny Gross from OracleLabs. Kenny Gross is an architect with OracleLabs, and he's going to speak today about autonomous anomaly detection for dense sensor IoT prognostics, after which we will have a brief Q&A. When you want to submit your questions, submit them in the Q&A area, not the chat, please. And then Kenny and I will see them, and Kenny will respond. All of our Analytics and Data TechCast should take about 30 minutes, including time at the end for questions and answers based on your submissions to the Q&A window or whatever. So please submit your questions there. As I said, it's being recorded. Afterwards, it will be posted on the TechCast archives page. So you can go back there, and if you missed it or you want to share it with some of your friends and family, you can go back to the archives and you can view it. We also post these things out on YouTube as well, so you can find them out there with the hashtag #ANDTechCast. Afterwards, we'll also post a PDF of Kenny's presentation out there on the same archives page. I'd also like to use this opportunity to recruit additional TechCast speakers. The philosophy, the reason we do this is because everyone has knowledge, expertise, tips, and tricks to share. We all use Oracle technology in one way or the other, and we all have knowledge and expertise, and we think that there's a sort of community sharing where we can all sort of benefit from that. So you can do that. You can share your knowledge and tips and tricks and such through these TechCasts. Just go to the TechCast page where you registered here, and then just above it there is a link where you can submit your own TechCast. Also, I'll remind you of this, but please come back in 2 weeks when we have our next TechCast. Shankar is going to be speaking about Oracle Analytics for the industry data models for market basket analysis with SQL pattern matching. So with that, I'm going to turn it over to Kenny. Kenny, take it away, please.
Thanks a lot, Charlie. Yeah, I'm Kenny with OracleLabs, an architect with our Oracle's Physical Sciences Research Center here in San Diego, where we, as Sun Microsystems, originally developed and actually built from the ground up the Physical Sciences Research Center, and most of the prognostic innovations that you'll see today have been developed since 2001, when we started the research center initially for prognostics of business critical servers and data centers. And as you'll see, we've spun off into other challenges in other industries. And I'm going to talk about a machine learning technique that is called MSET, and we for Oracle now call it MSET2, and I'll show you the differences between MSET and MSET2. The Multivariate State Estimation Technique, MSET, is a prognostic algorithm for time series databases, and I just wanted to make that distinction right up front. OracleLabs and other Oracle organizations have deep repositories of a lot of types of machine learning for classification type research and other techniques for time series. MSET is for time series prognostics and for sensors and other digitized time series. So this is not classification type machine learning. MSET, I had originally developed MSET back at Argonne National Laboratory in the 1990s. And since that time, it was spun off into a bunch of industries, and Sun Microsystems was the first company to pull MSET prognostics right into the hardware assets in the data center, IT assets, server storage, and networks. And in the year 2016, my original patent for MSET expired. Up until that time, for all of our applications at Sun and at Oracle, after we merged with Oracle, were licensed in. MSET was licensed in. After 2016, Oracle Legal gave us in OracleLabs the rights to redevelop a new and improved MSET2. And now MSET2 has significant competitive differentiation with respect to the former MSET1 and to all other competitive forms of machine learning. And that's one of the things I put in the abstract, and I'm going to show in this presentation several of the features that conventional machine learning cannot solve in terms of sensors and assets in oil and gas, manufacturing, avionics, and utilities. There are challenges in the signals that cannot be solved by other forms of machine learning, but Oracle's MSET2 can solve very readily and provably. This gives our customers in those industries an advantage and gives Oracle competitive differentiation because Oracle owns the intellectual property on these innovations that are integrated into Oracle's MSET2. And for my former colleagues from the hardware business in Sun and people who have been in other enterprise server businesses, this is like taking coals to Newcastle. Like, why would availability be important in data centers? But the reason I'm starting here about why availability is important is for those of you in the business units and the product teams, what you will find out, and I found out many times going to data scientists workshops with customers, whether it's in utilities, manufacturing, oil and gas, is initially there's a lot of smiles and people rolling their eyes because data scientists, I hate to say it, in many of our customer industries, think that Oracle, that's their grandpa's database company. And they sort of scoff at what could Oracle possibly know about prognostics. Well, it turns out, and you'll see in this presentation, Oracle was the pioneer for big data analytics, truly big data analytics. There are customers now who are struggling with the IoT revolution to expand their conventional machine learning to the scope of dense sensor IoT industries now. We've been doing this for 19 years. It turns out that a data center, the explosion in sensors happened in IT systems first, before it happened in any other IoT industry. When we first started, a typical server might have 10 or 20 sensors in, and that ramped up in a hurry as sensors became cheaper. And so now a typical pizza box size server has over 200 sensors in. Oracle's big $1 million M6 server has 3,400 sensors in, which happens to be the same number of sensors in a commercial nuclear reactor. And now a medium-sized data center has 1 million sensors in. So we in OracleLabs cut our teeth long ago on confronting and solving the challenges of dense sensor prognostics, where you need to scale the prognostics up to 1 million sensors. And as other industries are facing those challenges these days with the explosion in sensors, for example, one of Oracle's customers, Airbus, now the latest Airbus airplane has 75,000 sensors. A modern oil refinery has 1 million sensors. And in those industries, they are confronted with the challenges of how do we scale prognostics. We in Oracle and OracleLabs have done that a long time ago, but the primary motivator for Sun Microsystems and Oracle is availability is very important in a data center. Nowadays, we've got with horizontal fault tolerance in the boxes in the data center, it's not possible for one server or one rack to go down and bring down a data center. But when we started this research, when I came into Oracle back in 2000, that was not the case. And one big server could bring down a data center. And when I got recruited into Sun, part of the interview process was the candidate had to give a seminar. And I gave a seminar up at headquarters to a room full of computer scientists. And I'm not a computer scientist, I'm a nuclear engineer. And as part of my presentation on MSAT and advanced prognostics, I said during my presentation to this room full of computer scientists, I said, we can't have a nuclear plant shutting down because it's $1 million a day downtime for a nuclear plant. And all these computer scientists laughed at that. And little did I know at the time that when assets and data centers go down, and especially back at that time, if a data center went down, it's millions of dollars an hour in direct losses, and the indirect business losses were far greater. Our biggest catastrophe when we were still Sun was at eBay. eBay had all Sun servers, and their data center went down, and this became a CNN event back at the time. Their data center went down for 22 hours, and the losses were $4.5 billion. And it wasn't because of all the toasters and bicycles that people weren't selling during those 22 hours, but the advertisers and investors said, this isn't a good business model, and pulled out, and eBay's market cap dropped $4.5 billion overnight during a time when it had gone up steadily for 19 quarters. And so Sun did put very high goals around availability. And that motivated, Sun was the first company to pull MSAT right into the assets, and it's still active in many Oracle systems and networks today. This is just a cartoon overview of the types of industries that the original MSAT-1 was licensed into. I mentioned nuclear reactors. That's what I and my team originally developed MSAT for, was for nuclear reactors, and we had significant successes with nuclear reactors. And I want to mention the original bake-off that sort of started the ball rolling for MSAT. The reason I mention a bake-off is as I work with the teams in Teresa Short's OCS, or the Oracle Consulting Services, and with people who have teams in avionics, have accounts with oil and gas, utilities, and avionics. I always encourage that for proposing a POC with a large Oracle customer, propose a bake-off, because that's what wins their hearts and minds faster than anything else. If they have a bunch of signals and they have a competitive solution from GE or IBM or even homegrown solution, nothing catches their attention more than using exactly the same archive signals with MSAT-2 versus another tool. And that's what started MSAT in the nuclear industry. There was a large international bake-off sponsored by the U.S. Nuclear Regulatory Commission, the U.S. Department of Energy, and the Electric Power Research Institute. And there were many participants, and it was to find the most sensitive machine learning technique at that time. and with the lowest false alarm rate too. False alarms in all the industries Oracle serves are very costly, and they are nuclear plants too. And that's one of the hallmarks of MSET, is the absence of false alarms. And I'll show more about that in a minute. But talking about bake-offs, they did a bake-off and it had national laboratories in. It had EPRI, various utility working groups, and many university teams who were expert in neural networks. That was the biggest thing at the time in prognostics and machine learning. They gave all of us participants a CD that had 1 year of signals from all the instruments in the nuclear plant, in a real operating nuclear plant. They told all participants, you can train on the first half of the year, there are no faults in the signals, and in the second half of the year, they seeded 10 hidden faults. So it was like an Easter egg hunt to see whose techniques could find any of the 10 seeded faults. And when they had the final results from the bake-off, they down at Florida, Crystal River, Florida, and the NRC and DOE were there, many utility reps from all over the utilities all across the country. And my friend at Florida Power, who scheduled it, he asked me how did we do, and I winked at him and smiled, and he put me last, MSET last. So all these teams got up there with their fancy probabilistic neural networks, and not one of those teams was able to find any of the 10 hidden faults. And they used their slot to show the things that they did, and why they think if DOE would just give them 6 more weeks, they're pretty close to finding some of those faults. And so I was scheduled last, and MSET not only found all 10 of the seeded faults at the exact minute of introduction of the faults, but found 4 other instrumentation faults, incipient faults in instruments in the nuclear reactor that they didn't know about yet. And the Crystal River people went and checked those instruments and said, oh, wow, it does have a developing fault in it. So that's when MSET first took off. It went into other industries. Delta Airlines in 2002 licensed it. We all know that aviation has had black box flight recorders for probably the last 100 years, but the black box recorder doesn't do any of us any good if we're on that plane and they got to dig it out of the side of a mountain or out of the bottom of the Atlantic Ocean. Delta was the first airlines that instead of, they still put their signals in black box recorders, but they would beam the signals in real time through satellite links and monitor with MSET. And they've been doing that since 2002, and they have a recent publication showing how much operation and maintenance costs and avoided engine fault events that they've done over the last 17 years. And now there are contracts with Southwest, Air France, and Lufthansa, Disney theme parks. NASA. The reason I want to mention NASA here, NASA has been using MSET. I want to drop the name Decision Detective. Back in the late 90s, I and the CEO of Decision Detective, they licensed MSET. We got 3 contracts from NASA to get NASA into the space shuttle for sensor and asset monitoring. But the reason I mentioned Decision Detective is the largest use that is still very active in Oracle is in the Oracle Rack clusters, and Cluster Health Advisor, CHA. It's on Oracle's external websites, and it has been doing fantastic. That is the Decision Detective version that was licensed in by, we did a bake-off against OAA machine learning for Thomas Kurian, a 6-month investigation, and against support vector machines and neural nets in OAA, and MSET1 in all categories. Korean licensed it in for $2.5 million, and it's been extended and enhanced ever since, and is still in place for Oracle REC clusters. I'm just going to highlight a few of the industries that Oracle serves, in which MSET2 has high ROI for customers and competitive differentiation. One of those is utilities. And for each one of these, I'm just going to fly through the industries. We have technical white papers and executive message overviews for each one of these industries, and anybody can ask me about those afterwards. I'll be happy to send papers, so I'm not going to go in great depth in the industries. For the utility industry, there are a variety of high-value challenges that MSET2 does better than any competitive machine learning tools, and I list those here. Remaining useful life estimation, RUL, is valuable in a lot of industries where it makes a big difference if an asset such as a transformer in the grid or a $1 million GE engine on a Boeing jet shows some alert. It makes a big difference when that thing is most likely to fail. For an asset in the grid, a $7 million transformer, it makes a difference to the operations manager whether is most likely to fail next Tuesday or in 3 months. For proactive scheduling of preventative maintenance, the highest value from the machine learning is RUL estimation, and we have multiple patents on that using the output from MSET for RUL estimation with quantitative confidence factors. Load shape forecasting is important because utilities have to buy and sell continuously at spot market rates to make sure they don't have blackouts and brownouts. Provenance certification, bullet number 4, provenance of the data. I've been privileged to be working with Dieter Golick and other architects in Andy Mendelson's database organization. And one of the values that we anticipate when MSET is integrated with DB Query in Oracle's flagship database product is provenance certification for large-scale time series databases. By provenance certification, that means it's audibly, you can certify that the data has never been maliciously or accidentally monkeyed with for time series databases. You cannot do this with neural nets or support vector machines because of the stochastic optimization of the weights. But MSET is a deterministic mathematical algorithm, and so it's possible later to prove that nobody got in and altered signals, either for to avoid penalties from regulators or for financial gain, and that is important to our utility customers. Oh, and EMI fingerprints for detection of counterfeits. I'm going to mention that. I've got another slide on that. That has turned into a $200 billion a year problem, counterfeit components, and it happens in all industries, including safety-critical industries, including in Oracle's business-critical cloud data center assets and our competitors' data centers. And MSET2 for EMI fingerprints passively detects counterfeits from many types of electronic assets that come in from the supply chain. Manufacturing, there's a lot of ROI that's already been demonstrated in the field that you see here with higher availability, higher yield, lower scrap rates, and lower early life failures from the manufactured products. And again, OracleLabs has white papers on each one of these using real signals. I'll just mention here that This is the data flow for a cloud implementation of MSET2 for real-time streaming analytics. And for streaming analytics, a lot of Oracle customers who are adamant about not migrating to the cloud, one of the perceptions they have is if they're doing real-time streaming analytics with sensors on the plant floor or in the grid for the utility, that if they go into the cloud, they can't possibly meet the throughput requirements and latency specifications. It turns out MSET2 is very lightweight compared with other machine learning algorithms, but we in OracleLabs, we have an ongoing collaboration with NVIDIA, and we are measuring speed-up factors in Oracle's cloud with the GPU shapes, and this is going to be presented at Oracle Open World. We're getting fantastic speed-up factors of over 100 using OCI's shapes that involve NVIDIA GPUs. And for most customers, if you have customers who don't want to go in the cloud because they think they won't get high enough throughput or low enough latency, we can really open up their eyes, because it's very likely the latencies will go down in Oracle's cloud and the throughput will go up. They can have even more signals streaming at faster rates. And I just wanted to mention, this is an overview of the background with MSET1 above the orange line here. It was licensed out to a bunch of areas, including Sun Microsystems and Oracle. In 2011, GE bought the rights to MSET for $220 million, and that became the foundation for GE Predicts. And many of you in customer account teams will find customers that say, oh, we're using GE Predicts. If so, we would love to do a bake-off with them, because MSET2, that's below the line, has substantial advantages, not only over conventional MSET1, but other machine learning algorithms. I'm not going to go into any mathematics in this quick overview. MSET comprises, the MSET core is for dynamic signals, the SPIRT is for stationary time signals, and gets the lowest mathematically possible, and we've proven this in refereed journals, false alarm and missed alarm probabilities. And that's the real challenge for prognostics, is high sensitivity for detection with low false alarms. False alarms in all the industries that Oracle serves causes revenue-generating assets to be taken out of service unnecessarily. And that's a big problem in utilities, aviation, and other industries. And we have the lowest false alarm probability with the highest sensitivity for incipient defects. I just wanted to mention, we get a lot of questions from presentations to customer team. Oh, can you work with my types of sensors? And this is an eye chart here. I just want to say that any types of physical transducers in any industries Oracle serves, MSET2 has already worked with those types of sensors. So I'll turn it around and say there's no types of sensors that produces digitized time series signals that MSET2 cannot work with. MSET2, you'll see in our refereed journal papers, gives an earlier warning, and that's the foundation for being able to detect incipient problems so they can be repaired proactively repaired before it turns into a catastrophic failure. And the final thing that I wanted to mention in this quick overview, and I will say that the PDF that Charlie's going to post on the website has a bibliography that has papers to each one of these features that I've mentioned in this overview. But EMI fingerprints, as I mentioned at the outset, it's a $200 billion a year problem. Oracle's EMI fingerprint solves that problem and is able to detect counterfeits in utility assets, IT assets, and gives a unique and unambiguous indication that if counterfeits sneaked in during the supply chain, this will catch it. So, Charlie, that's my overview of features, and I can't really see the Q&A screen here, but have any questions popped in? And if not, I'll be happy to follow up through email with any technology questions after this presentation.
All right, great. Thank you, Kenny. Yeah, there's one question here. Will this be available as general product from Oracle? I can talk to that a little bit, Kenny, or if you want to describe anything.
Oh,
how do they get the hands on this?
Please do, Charlie. Go ahead.
Okay. Well, Kenny has some links and some different things where you can work through Kenny through consulting engagements and such. But also, I think we've made this public before, so I'll state it again here. We've sort of rewritten some of MSET a little bit, and to put it inside the database, this will be a new feature in the 20C version of the database, which will also be in the autonomous database in the, I'm going to say, months ahead, to be very sort of, loosey about that. So you'll see this algorithm in a database near you. We also have the ability to export models and run them in other locations, and that's sort of new feature. So we're very excited about this work. Kenny, I don't have any. I'm just watching the wire here for any other questions. Don't see any. Do you have anything else you want to offer? Otherwise, we'll sort of keep to our 30-minute goal, and I'll just sort of close it out. Anything else from you?
Oh, just to mention, like you and I were talking, if people would like to see any demos or other good stuff on MSET2, Bill Wimsatt, his team in the Oracle Innovation Hub has the nicest database of demos and background on MSET2. And I mentioned the demo because they have done a spectacular O-tube demo that uses real signals from the utility sector, and get in contact with Bill Wimsatt, and their demo is pretty awesome.
All right. Then I am going to close this out, but before I do, I'm going to first remind you of our next TechCast. It's going to be on Thursday at the same time, same TechCast channel here. We're going to have Shankar Samayalulla, Shankar, who is a very good architect in our industry data models team for the advanced analytics. And he's going to be talking about revisiting market basket analysis with SQL pattern matching, so that's kind of exciting. And he's going to go into a fair amount of detail on that. So please join us then. And lastly, I just wanted to thank Kenny for being such a great speaker today, and recruit anyone else that has. These are meant for technical sharing, for sharing some code. Here's how I solved a problem. Here's a clever thing I did. Maybe I'd be happy to share that with others. So if you do have any partners, customers, Oracle people, anybody that wants to share their knowledge of Oracle technology, please submit your own TechCast, and we'll put you on the same TechCast channel. With that, I will close this out to stop the recording, and thank you all very much for attending.
Thanks.